Hi everyone. So far in our videos, we've talked about limits in general. We're not talking about just one-sided, but we've been talking about from both sides. We kind of did some hand waving and talking about how a limit only exists if we approach it from the left and from the right, we get the same answer. Well, now we're going to actually define one-sided limits. The limit from the left, or the right, the left-hand limit, and the limit from the right, or the right-hand limit. These are very important because they give us more information. Let me show you an example. So here we have a function, x over the absolute value of x. I don't expect you to graph this, but I expect you to be able to read it. So let me read for you first the paragraph. One-sided limits allow us to describe functions that have different limits at a point, depending on whether we approach the point from the left or from the right. One-sided limits also allows us to say what it means for a function to have a limit at an endpoint of an interval. So first of all, I want you to look at this function. And I want you to ask, what is the limit of the function in the image as x approaches 0? So like I usually do, I'm going to mark x equals 0. So that's the vertical axis or the y-axis. As we approach this axis from the left, what is our limit? Well, if we approach this axis from the left, we end up approaching this point here. So our limit here would be equals -1. If we approach from the right-hand side, this y-axis or x equals 0 point, so as we let x approach 0, we follow the curve, and we end up approaching this point here. So the limit up here from the right would be a 1. So what does this mean about a limit in general? The limit in general does not exist. Remember, we use D and E to denote does not exist. The reason is there's not one single value we can give. It's two different values. So to give more information, we can actually specify what the limit is from each direction here. So first of all, the right-hand limit from the right, is denoted by this little plus sign here. So when you write it, you're going to write the limit is getting squiggly, as x approaches 0 with a little plus sign. So instead of an exponent, we put a plus sign up there. This means from the right-hand side. So this is the right-hand side, meaning if you're trying to approach x equals 0, from the right would be over here. From the right, we approach x equals 0, and we approach the limit equals 1. So the limit as x approaches 0 from the right for our function x over the absolute value of x, we found the limit is +1. However, on the other hand, literally, if we approach from the left-hand side, that would be over here on our picture, and we approach this value here, which is -1. So if we were to write this out, we would write the limit as x approaches 0, that's the x value we're approaching, but we're approaching from the left. So to denote from the left, we put a little negative sign. So you can see the negative sign here. So this means from the left, and the plus sign means from the right. It's very important that you recognize it as from the left and from the right, because some students get that mixed up with other things, like moving in the direction of right and left. No, it's from the right and from the left is what these denote. So our function we write here, oops, wrong color, x over the absolute value of x. So the limit of x over the absolute value of x as x approaches 0 from the left is equal to, well, if we look at our picture, we approach this point here, which has a y value of -1. And that would be your limit. Another purpose of a one-sided limit, a left-hand limit or right-hand limit, is this one right here. If you look at the image, you'll see that our domain, the x values where this function is defined, is very limited. It's only from -2 to +2 that we have points. If you move to the left over here, we have no points, and over here on the right, we have no points. So the purpose of a left-hand and right-hand limit in this case is to actually tell a reader, to tell someone what is happening at the endpoints here. These endpoints we can't approach from both sides. We can only approach from one side, either the left side or the right side. So an in general concept where left and the right side agree doesn't make any sense. So in this case, where we are at a boundary point, we simply discuss the existence of a limit as being either the existence of a left-hand limit or a right-hand limit for the endpoints of the domain. So we have here a function, square root of 4 minus x squared. You might see this later in the course. This is a semicircle, the top half of a circle. And what we're going to do is we're just going to write down what's happening here. We're going to find the limit as x approaches -2. Now, in general, this doesn't make sense, but we can approach -2, that x value, from one direction. So I want you to think about it for a second. Can you approach -2 from the left, or can you approach it from the right while following your curve? Well, if I get on my curve here, I'd have to get on over here. And as I follow, I'm coming from the right towards my x value. So for -2, we would talk about the limit from right. And this would be the general limit as well, because this is a boundary point. There's nothing from the left to approach this, to even talk about. So the limit of f of x as x approaches the x value of -2 from the right, I want you to look at your picture and follow your curve. So if you follow the curve towards your x value, what function value are you approaching? Well, you're approaching the function value at this point. Be careful, common mistake is to give the wrong number. What is the function value at this x? The x is -2 that you're approaching, but the function value is the y value of 0. So the limit here would be 0. If we were to approach the other boundary point, x is +2, so the limit as x approaches +2, are we going to approach this point from the left, or are we going to approach it from the right? Well, let's get on our curve and go towards that point. So if we get on our curve, we get somewhere around here. So x marks the spot. Follow the curve towards our x value. Now we're coming from the left. So we would denote this as the limit as x approaches 2 with a little minus sign, denoting from the left. For our function f of x is equal to, what is the function value as you approach x equals 2? Well, you're approaching this dot here, this point. This point has what y value? Remember, y value is always the limit. The y value at that point is 0. Okay, now these are two different limits that we found, so we would not put them together. X is approaching two different values. So the limit as x approaches -2 from the right is 0, and the limit as x approaches +2 from the left is 0. So those are two examples of how you would write boundaries. What about any other point in this graph? Well, any other point you were to find, you would find a limit as long as you're looking at an x value between -2 and +2. So for example, if I pick this point right here, I can approach this point from the left, whatever x value this might be. Let's call this c. And I can also approach this point from the right. If I approach from the left, I approach this point here. If I approach right, I approach the same point. So that point has a y value, and that y value would be my limit. No matter what point you look at on this curve, if you approach from the left and you approach from the right, you end up at the same limit value. The only points that were really interesting in this case are actually the boundary points. Everything else has a limit, and the limit would exist. All right, so we have a theorem here. And we've actually been talking about this throughout the videos, but we've been doing it with a little bit of hand waving. So it says, suppose that a function f is defined on an open interval containing c. So the function has points around c. C itself, it might not be defined. It might be an open circle, it might be an asymptote. Who knows? But it might have a problem at c. Then the function f has a limit as x approaches c if and only if the left hand and right hand limits there and these one-sided limits are equal. So in general, our limit exists if the left hand limit and the right hand limit are the same. So if you approach from the left and you approach from the right, you get the same limit. The general limit exists. So we've been doing that, but now we've formalized it, and that's the only change that you should see here. Now, this does only appear at interior points. So in the picture problem we just worked, we looked at boundary points. So let's talk about a boundary real quick in this theorem. So at a boundary point of its domain, a function has a limit when it has an appropriate one-sided limit. So like we said before, we can only talk about the left-hand limit and the right-hand limit on the boundaries here. So that's the only thing we would describe to talk about the limit in general of a boundary point. So what we have here is an example graph where we have a lot of interesting things going on, and we're going to use these special points to be able to talk about some of the limits that we've been learning. So let's look at the notation here. Do you remember what this little plus sign means? Think about it. Actually, feel free to go ahead and pause the video and go ahead and try these problems on your own and come back and replay it once you've giving it a shot. All right, so if you've tried it, this little plus sign means from the right. So we're going to let x approach 1 from the right. Well, I'm going to mark 1. Use a different color. So this is where x equals 1. This is what we're trying to approach. From the right, so over here to the right of that, I'm going to get on my curve and move towards my x value. What function value are we approaching? Remember, get on your curve and go towards your x, following the curve. This open circle is the function value we're approaching. Just because it's an open circle does not mess up the limit. You are still approaching that circle, that hole. So that hole has a function value of 3, so we would say there that the limit was 3. If we approach from the left, the same x value, still approaching 1, but from the left. So get on from the left and approach your x value. Notice we're approaching the same open circle. That is still going to be your limit. So our limit from the left is 3. What did we just talk about? If the limit from the right and the limit from the left are both existing and they're the same, we can say that the limit in general is 3. Notice it has nothing to do with this random point hanging out up there where x does in fact equal 1. The limit is what you're approaching, not the actual function value of at that particular x necessarily. All right, let's try another one. So this time we're looking at -2. Again, we're approaching from the right first. So let me mark -2. So -2 is this one right here. Oh boy, lots of interesting stuff going on here. So x is -2, and we're going to start from the right. So to the right of -2, I'm going to get on my curve and go towards that x value, following the curve. So what function value am I approaching as I approach this point? Well, this point has a function value of -1. Always give the y value for your function value. So -1 is going to be the limit as x approaches -2 from the right. What about from the left? Is anything going to change? Are they going to be the same? Are we going to have a limit in general? Well, let's look at it. So -2, we're going to get on from the left. Oh boy. We're going to follow the curve. What is this trying to show us here? It's up and down motion. Remember, this is the oscillating that we talked about. When a function is oscillating, like we are trying to illustrate in this picture here, what does that mean? That means no matter how close you get to x, you always go up and down again. Get a little bit closer. You go all the way up and all the way down again, whatever the values are here. So we're going between 2 and 4. So you go all the way up to 4, all the way down to 2. Get closer. You go all the way up to 4, all the way down to 2. No matter how close you get, you always go up and down again, which means this function here is not approaching anything. It's going to keep oscillating between the highest and lowest values that it is oscillating between. So what does that mean about a limit? Do you remember? If your function is oscillating as it approaches a certain x value, we say that the limit does not exist because it's not approaching a single number. It is jumping between the two values, 2 and 4. Well, not jumping, but moving quickly between them, back and forth. All right, so we found the limit from the right was -1. We found the limit from the left did not exist. What does that mean for the general limit? According to the theorem, in order for the limit to exist in general, they both have to exist and they have to be the same. Because the left and right do not match and one doesn't exist, the general limit does not exist. All right, we got one left. We're going to talk about x approaching 3. All right, I'm going to mark 3. Let's see, he's over here. So this is who we're trying to approach. X equals 3. Remember, the plus sign means from the right. All right, so we're going to get on our curve from the right of x equals 3. So somewhere maybe over here, we're going to follow our curve towards the function value. So again, it's a hole. Does a hole mess up a limit? No. You can still approach a hole, just don't worry about getting to it. You'll fall through the hole. Limit, you just have to get closer and closer and closer. The closer we get, what function value are we approaching? Well, the function value of the hole, which is -3. So -3 is the limit from the right. Remember, the minus sign means from the left. So what I want you to do is approach x equals 3 from the left. So let's get on our curve maybe from over here and approach, oh, we're approaching a different point, which means we're approaching a different function value. This hole has the function value of 1. So the limit from the left is 1. So the limit from the right exists, the limit from the left exists. However, they are different. Because they are different, what does that mean about our limit in general? Remember, in order for the limit in general to exist, it has to be the same limit left and right. So because they are different, this means that the limit in general does not exist. Another way to look at it, there's a gap here from the left side and the right side. Because there's a gap or a jump, you cannot say that the limit exists. The limit does not exist there. So I hope that helps you. Those were some great examples, bringing it all together. If you have questions, reach out. Keep working, practice, and I'll see you in the next one.